Hi, Algebra 1 students. I hope that you're having a good Monday, even though it's a little bit rainy outside. It certainly makes doing your homework a lot easier. Sorry this is so late. Sometimes it just takes a long time to get it to you. So we're going to get started, but I want to tell you a little bit about what our plan is for the rest of the year, because as you know, 2 weeks from today will be our last day of class. Now, I normally, of course, would be giving you a final exam, but one of the main purposes of having a final exam is that you are tested on the material from the semester in class with a limited time period, learning how to take a test in class with time constraints so that you learn to manage your time. And of course we can't do that, and we haven't been doing that, and we haven't had regular class. And I just want to say that under the circumstances, you are all doing amazingly well on algebra, learning it on your own just with videos and some Zoom tutoring and whatever other resources that you're coming up with. It's all of you, it's a testament to you and your families how committed you are to your education. At any rate, because of that, we're not going to have a final exam this year for this spring. So what we're going to do is we've already started chapter 13 last week, and we're going to do lesson 13.2 today, 13.3 on Wednesday, 13.4 next week, and then the last day of class, which is June 1st, we will do an optical illusion project. So you're going to learn how to create your own optical illusion. That's a mouthful. So how do you make something that's 2D on a piece of paper look like it's 3D? We're going to do that. So hopefully you will be getting your chapter 12 test to me in the next day or two, and then all you have to do is your homework for these last few sections. And I just want to say also that chapter 13 is quite important. I'm pushing to do this because I know what is ahead of you in Algebra 2, and I want you to have great success. And probability concepts are not all easy. The first lesson was relatively simple, but it's going to get more complicated from there. And I want you to have some exposure, to have some confidence in doing some of these problems, and so that when you get to Algebra 2, you will just be building on that good skill set that you've already started this year. All right, so let's get started, and we're going to say a prayer. Father in heaven, I just thank you that you're faithful. I pray for all of my students that you would help them to focus and listen and learn well, and they would have great success on chapter 13 and really enjoy it because it actually has some fun elements to it. And I pray that you'd strengthen me and help me to be the very best teacher that I can be. In Jesus' name, amen. Sorry about that. Lord, help me not to stumble over my words today. Thank you. So let's get started. Okay, now I already wrote down most of the problems. So I'm going to go pretty fast because a shorter video gets uploaded faster. I've said that before. So if you have to pause it or rewind it, feel free to do that. All right, so lesson 13.2 is called Finding Probabilities and Using something called Permutations. All right. So the first thing we're going to do is define that word. A permutation is an arrangement. I'm going to change colors here. Okay, is an arrangement of objects in a particular order. So order is important. And what we're going to learn on Wednesday, order is not important. So it's very critical, very important that you know the difference. Okay, so it's an arrangement of objects in a particular order. Now you might wonder, well, what is that? What does that mean? Well, here's an example. What are 6 possible permutations of the letters A, B, and C? Well, let's write them all down. We can obviously have A first, B, and then C. Or if we had A first, and then we could switch the C and the B. That would be another permutation. What if we had B first? So we had B, A, C. And how about B, C, A with the B first? And then the last ones would be if C was first. So we'd have CAB and CBA. So those are all 6 permutations. So each one of these is what's called a permutation of A, B, and C. It's a different way to put them in order. Each one is. Okay, let's do an example together. Consider the number of permutations of the letters in the word July. J-U-L-Y. In how many ways can you arrange all of the letters? Well, let's talk about it. So we have the number of permutations. How many different ways can we write those 4 letters? Well, so let's say we had the first letter. How many choices do I have? I have J, U, L, or Y to choose from. So I have 4 different choices. Okay? Now, I would multiply that by how many choices I have for the next letter. Well, let's think about that. If one's already been chosen, how many letters are left? There's only 3 letters left after one has been picked out in the first letter. So there would only be 3 choices. So if we picked J first, we would only have U, L, or Y. If we picked Y first, we would only have J, U, or L. Do you get the idea there? Now for the third letter, how many would we have? Well, we only have 2 letters left out of the 4. Okay? So the first 2 have been picked. So there's only 2 choices left. So there's a 2 that goes here. And then by the time I get to the last one, there would be just 1 letter left. Now, why did I do this? You're going to figure this out. It's hard work to write them all down. Now, if I multiply 4 times 3 times 2 times 1, I get 24 different permutations. Well, how do I check that? How about if I write them all down? You don't have to, but guess what? I already did. There they are. The J's are first, the U's are first, the L's are first, and the Y's are first. And each one has all these other different orders. So if you add these all up, I get 24. So it works. All right? If I take the first one and multiply it by the second and the third and the fourth, it works out to be the same number as if I had written them all down and figured them all out. Okay, so let's talk about another problem. What if I said this? In how many ways can you arrange 2 of the letters of July? Okay, only 2. So for the first letter, how many choices do I have? Well, I have J, U, L, or Y. So I would have 4 choices there. J, U, L, or Y. And then the second one, how many choices would I have? The second letter, I've used 1 letter, so I would have 3 left to pick from. So that would be a 3 there, just like in the last example. But now I'm done. Okay, I only have 2 letters. I'm only picking 2 out of the 4. So I'm not looking like above if I wanted all 4 letters in my arrangements. You see how I have 4 letters in all my arrangements? This time I only want 2 letters. How do those look? Well, it looks like this. So J with U, U and J, and I wrote them all out and I switched them all around. If you add those all up, you get 12. So do you see the process? That if I look at it by the letter and multiply them, I don't have to write it all out. There is a formula. Okay, so we're going to get to that in a moment. So I want you to go ahead and do these OYOs right here. Go ahead and write them down. In how many ways can you arrange the letters in the word mouse, M-O-U-S-E? And number 2, in how many ways can you arrange 3 of the letters in the word orange, O-R-A-N-G-E. So go ahead and pause the video and work those out, and we'll come back in just a moment. Okay, so let's figure out this one. I would have the first letter, I have 5 choices. The second letter, I have 4 choices. The third letter, I have 3 choices. The fourth letter, I have 2 choices. And at the end, there's only 1 choice. So if I wrote them all out, I could arrange the letters of M-O-U-S-E 120 ways. So that's 120 permutations. Okay? In how many ways can you arrange 3 of the letters in the word orange? Well, if I had my first letter that I pick, and my second letter, and my third letter. For the first letter, I'm starting from the beginning. So how many do I have to choose from? 1, 2, 3, 4, 5, 6. So I've got 6 choices at first. Now, one of those have already been picked. So in my second letter, I only have 5 left. I don't know what it is yet, the first letter, but I would only have 5 left after I picked that one. So the second letter, I can only pick 5. And then the third letter, I can only pick from 4. So I end up with 6 times 5 times 4, which is also 120 ways or permutations. It just happens to be the same answer just by chance. Okay, so there's a formula here. I have a new symbol that I'm going to teach you today that you probably haven't seen before, and it's called factorial. Okay, so if you see like 4 and an exclamation point, that means factorial. And what that tells you that it means is take whatever number that is and multiply it by itself and all the numbers underneath it. So if I had 6 factorial, that would mean 6 times 5 times 4 times 3 times 2 times 1. You get the idea. Okay, now for this permutation problems that we're looking at, we're going to use factorials, and here's how they look. Okay, the formula for the permutations for n objects is this. The permutation of n objects is n factorial. So what that means is for the number of permutations of 5 objects, what do? So I pick 5, I'm going to pick all 5, and I have 5 objects, and I'm going to pick all 5. So that ends up being 5 factorial, which is 5 times 4 times 3 times 2 times 1. Okay? And we can figure that out. Okay, so if you want to figure out how many different ways you could put 5 letters in order, it's 5 factorial. If you wanted to figure out how many letters, if you had 3 letters, it would be 3 factorial. how many different ways you can put things in a particular order is the factorial. That's like what we did with the first one in July when we got 24, okay? Now there's a second formula. And that is this one. The formula for the number of permutations of n objects, but I'm only going to take r of them, okay? So, let's see, it would be permutations, n r equals n factorial over n minus r factorial, okay? So let's look at it. What does that mean? That, for example, the number of permutations of 4 objects, but only taking 2 of them. What does that mean? That means, so I've got n and r. So 4 objects would go 4 here, and r, I'm taking 2 of them. I'm going to put 2 there. That would be n factorial over n minus r factorial. So I end up with 4 factorial over 2 factorial, which is 4 times 3 times 2 times 1 over 2 times 1. Now these cancel out, see? And I'm just left with 12. Okay? When you're only taking 2, the number of permutations will go down than if you had had 4. Okay, so let's look at an example of how this works. I already wrote it down, so you can go ahead and write this down. Your band has written 12 songs and you plan to record 9 of them for a CD. In how many ways can you arrange the songs on the CD? Okay, so the number of songs, the number of objects or songs is 12. And I'm taking 9. So n is 12 and r is 9. So now I'm going to use my formula, which is going to be 12 factorial over 12 minus 9 factorial. Now I want to show you something. Well, we're just going to do this. So 12 factorial is 12 times 11 times 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. And this is 12 minus 9 is 3 factorial, and that is 3 times 2 times 1. So I'm just going to cancel these out. Now you are allowed to use a calculator for this. So when you multiply all of these together, and you get 79,833,000. That's crazy, isn't it? With 12 songs, the number of ways you can put them in order is 79 million if you just choose 9 of them. I can't even imagine that. So anyway, we did see that with 4 things, you pick 24, it just becomes exponential. Okay, so I want you to go ahead and try one of those. Do an OIO. Suppose you had 15 songs and you will record 7 for a CD. And how many ways can you arrange the songs on a CD? So go ahead and try that one, and we'll come back in just a minute. Okay, let's do this. So the number of objects I have is 15, and I'm only taking 7 of them. So I have the permutation for 15 to 7 is 15 factorial over, whoops, I'm sorry, 15 minus 7 factorial. So that is 15 factorial over 8 factorial. So if I write that out, I'll have 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then I've got 8, 7, 6, 5, 4, 3, 2, 1. So all of these cancel. So I'm left with these to multiply. And on my calculator, I got 32,432,400 permutations. Okay, there's one more type of problem I want you to do. Now we're going to combine our understanding, our new understanding of permutations with what we learned in the last lesson, which is probability. Okay, so here we go. For a town parade, you will ride on a float with your soccer team. There are 12 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the school chorus is second. Okay, so that means that I have my soccer team first on the first float, and then I'm going to have the chorus, the school chorus is going to be second, and then I'm going to have the remaining 10 floats, and those are all random. So I need to include those, but the order doesn't matter of those, okay? So let's do a little review here. Probability is favorable outcomes over possible. This is theoretical now, not experimental. So what I want out of the total, you know, if I've got a bag full of marbles, what's the chance I'm going to pick a red one? Well, the red one would be what I wanted. That's favorable out of the total in the bag, which would be possible. Okay, so let's talk about what is favorable in this case. Okay, so first I want the soccer team and then I want the chorus, and then I want everybody else, right? I drew that up here, right? So how many chances can I get? How many permutations, how many chances do I have to have the soccer team first? Well, there's only one soccer team. So I can only pick 1 out of 12, right? All the others are not the soccer team. There's one soccer team. They go first. What's the chance that I'm going to pick the chorus next? Well, how many chorus floats are there? How many favorable outcomes do I have? There are 11 left. Out of the 11, how many are the chorus? Just 1. So there's only one possibility there of having the soccer and then the chorus. Now all the others. How many are left? 10. And how many different ways can I represent those 10? Well, they can be in millions of different ways. So that would be 10 factorial. What are the number of permutations of 10 to 10? It would be 10 factorial. Okay? So then my total answer there is 1 times 1 times 10 factorial. That's what I'm looking at for favorable. Okay, now, I ran out of room. Let's go down below. All right, so what are the possible outcomes? So I have favorable over possible. And that would be the chances of picking anything random at all, right? So that would be 12 factorial. Okay, anything in any order, just all the different ways I can have things, the floats in a different order. It's not favorable, it's just possible. I wouldn't have maybe I would have the soccer team first, maybe I wouldn't. Maybe I would have the chorus second, maybe I wouldn't. Okay, now let's do the probability. That is favorable over possible, which I've already said that. Let's just put it together. Favorable was 10 factorial out of 12 factorial. This is not the number. I'm not looking for just a permutation. I'm looking for a fraction. I'm looking for a, I am looking for a probability. Sorry about that. That was the doctor and I just can't answer right now. Okay, so what does this mean? This means 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1 over 12. 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay? So what can I do with those? Well, I can cancel all of these with all of these. So what am I left with? Everything's canceled, I'm left with 1. And then I'm left with 12 times 11, which is 1 out of 132. So what is the probability that out of 12 floats, I will have soccer first and, chorus second? The probability is just 1 out of 132. Not very likely. Okay, now I want to go back to this really quick because you can make this much simpler and much shorter. Watch this. I can write 10 factorial over 12, 11, 10 factorial. So instead of writing all those out, I can just do this. And what am I left with? Same answer. So you don't have to do that. Once you get good at it, you can do it like this. Okay, the last thing I want you to do is this OIO. What if there are 14 floats in the parade? What's the probability that soccer is first and chorus is second? So go ahead and pause the video and figure that out. All right, let's talk about this. Favorable outcomes are going to be 1 times 1 times 12 factorial, right? Soccer first, chorus second, then all the others in any order. So I end up with 12 factorial. What are my possible outcomes? Well, possible is I have 14, so that would be 14 factorial. Okay? So it's all my permutations, right? Because P of 14 to 14 equals 14 factorial. So my probability, which is favorable over possible, is 12 factorial over 14 factorial. And how does that work out? Well, let's see. This is 14, 13, and then 12. Oh, look, they're both the same there. I can just cancel them out. I end up with 1 over 14 times 13, which is 1 over 182. even less likely. Okay, so that's the end of our lesson, and I will send you the homework, and I hope you have a great Monday. Bye now.